Hi folks, thanks to be here for this talk about faster Maven builds. I'm Nicolas Frankel. I've been a developer for 2 decades, and since a couple of years I'm also a developer advocate. And though I'm a developer advocate, I still do some research around very focused areas such as like builds. I work for the Apache API. I work on the Apache API 6 project as a developer advocate. If you don't know about Apache API 6, it's an API gateway by the Apache Foundation. Today I won't talk about it, but if you are interested about API gateways, I suggest you have a look at it. So why should we care about build time? And for a long time, I didn't care that much, to be honest with you, because I thought, hey, it might take 10 minutes, it might take 15 minutes, might take 20 minutes, and actually it's asynchronous. I don't get like instant feedback in all cases, so I don't care that much. It's not going to change the build process or the delivery process. But actually, I read a couple of blog posts that changed my mind, and the point they made was that the build time is actually the limiting factor in your continuous delivery or continuous deployment process. And it makes a lot of sense. I mean, probably not a lot of us are doing continuous deployment or even continuous delivery, but if you do, you want to have the fastest build possible. So today, what I want to provide you with is actually two parts. The first part is like a very quick win. So how can you easily improve your build time without much investment or at all? And another part is if you are already fiddling with build time, if you're already close to the maximum, you thought for thoughts to further improve. Our agenda is in 2 parts. The first part will be about how you can do faster builds on bare metal outside of container, like on your computer. And the second part will be dedicated to in container building, because I've seen that there are completely different approach to both, and what applies to one doesn't naturally apply to the other. So let's start with what we are mostly familiar with, how you can build fast outside of your container, bare metal building. In this talk, I will be using Hazelcast sample, and for that I have this project, Hazelcast code sample. The interesting stuff is that it has a lot of modules, and actually in some of the modules you are using snapshots. So in one of the technique, we will see that it's interesting. The protocol itself is, I will run it 5 times. If you want to do the benchmark at home or in your organization, and I advise you to, because what works on this project might not work on your project, and if you have several different projects, also each of them might need different optimization. Please do that, but for the purpose of this talk, it's good enough. 5 times. Between each run, I do an MVN clean, so I start from scratch again. And very important, I start with all the dependencies already loaded, because otherwise then you are measuring the network download speed in each run, and you won't see much difference, and especially since at home I don't have such a very good network. So let's do the baseline. I won't do it in front of your eyes because it will take a pretty long time, but imagine that I do MVN test in this project at a specific commit with the snapshot and whatever, and presto, it gives me around 2 minutes. So yeah, it's pretty consistent actually, and yeah, I've got 2 minutes of build time, which again is the baseline. It's not good, it's not bad, it is as it is. The first thing that we can improve is by using all CPUs. I mean, nowadays we have like every developer, I hope that every developer has a multiple core machine, but Maven was designed at a time where actually you probably had single cores only, and so it's single threaded for this reason. But it's very easy. You can leverage the power of your cores by using like multiple threads. You just need to instruct Maven to do so. And so you have these like -t available here. And you can check yourself the documentation, but basically here says 1 thread per core. So you can set like relative to the number of cores, which is good depending on the machine you're running on. You can set an absolute number, it's up to you. So let's run it. And here are the results. And we see that even without doing any change, we drastically reduced the time it took. So here I have my machine has actually 16 cores, if I'm not mistaken. And yeah, I just like more than half the build time. Of course, it means that your build process needs to be like threading friendly. You cannot do like interesting stuff by yourself, locking or whatever. Everything needs to be parallelizable. So that works for the build itself, but we can also do the test execution in parallel. Again, by default, Surefire runs all the tests sequentially, so we can override it. And you need to say, hey, you can parallelize everything. Here you can again say it's relative to the number of cores, or you can set the absolute number. Here I've decided to set the absolute number, and presto, I've got this result. And this is again very similar to the baseline. And in that regard, in the context of the project, the reason is probably that I don't have that many tests. So like running them in parallel is not that interesting. So if you have a high number of tests in regard to the like build time, then probably it will be much more interesting. That's why I told you, please do everything that I show you in your own context in the project of your project or of your project, and the approach that you will take is probably very dependent on each project. So for each project you might adopt different approaches. In my context, it's not that great. Another optimization technique is to check the snapshots. So as I mentioned, the project I choose is on purpose. It depends on snapshot dependencies. And the thing is, Maven will check every time if there is a new version of the snapshot available. Even if it doesn't update it, it will check. So the idea is to move offline. And there is a little joker character, because actually what happens is there is a bug open since ages, and really like more than 10 years, that if you use offline, and not everything is offline, so you will probably have some checks anyway, but for our purpose, it's more than enough. And again, because I'm using snapshots in my build, then the results, they are quite good. I improve the speed. So the baseline was around 2 minutes. Here I shaved off around 15 seconds, which is quite good. And again, it doesn't cost me anything. The next approach is to think about the JVM itself. So we are using the JVM to build, but the problem of the JVM is it was designed for long-running processes. And our build is probably not that long running. I mean, again, 2 minutes might seem a lot to you, but it's not that long running. So there is no time for the JVM to optimize itself and to compile to native code and to actually like have performance improvement over time. And so the idea is, hey, we can discard some optimization. So what you can do is you can create a dedicated folder and then you create inside this jvm.config file, and inside you pass the compilation parameter, sorry, not the compilation, the JVM parameters you want Maven to use. So here I use those ones. You can use other ones. If you are a JVM guru, you probably might be much better at optimizing this part. But in my case, I improved the build time a bit. Again, the baseline is around 2 minutes. Here, again, it's between like 15 and 5 seconds each, which is not that bad. On the opposite side, what we can do is, hey, we have discarded optimization because a build is not a long-running process, but what if we like kept a running warm JVM running all the time? And it makes a lot of sense. The idea comes from Gradle, and I dislike Gradle, but they have good ideas, and they're like Maven, like took it from Gradle. So there is a dedicated project called Maven daemon, and it was recently like embedded into the main Maven project. So congrats, because it started as a real like side project. And there are tons of ways to install it. Here I've installed it with Homebrew on my machine, but depending on your system, I mean, use whatever package manager you want. Probably there is the MVN daemon package for your system. So instead of using MVN test, what I will be using is MVND test. So I'm completely ignoring the Maven wrapper in that case. And wow, that's really, really great. I mean, I come from around 2 minutes to 30 seconds. I've kept the build time by a fourth. So, sorry, I've cut the build time by 4. So, like 75% optimization. So here, wow, that's lots. The baseline is 2 minutes, and now I have 30 seconds, around 30 seconds. So that's 1/4 of the original build time. And of course, it comes from keeping a warm JVM. So the first run I discarded it. I don't show it here. Here is when the JVM is already warmed up. Another optimization is by default the Maven daemon uses, I think, all the threads. Uses all the core minus 1. So one of the optimization that I used, it already is reused by the Maven daemon. And here is the aggregated results. So I've shown you the average for each approach. I've shown you the deviation because sometimes you have a high deviation, sometimes not that much. And again, from the baseline. Also, what I wanted to try, and you can see in the latest 2 columns, is what if you try to use several of those parameters at the same time. And you can see that actually the best way is to keep the JVM warm. So the JVM parameters that say, hey, like, don't try to optimize. No, it's better because we keep the warm JVM, and it makes sense to keep them like optimizing all the time. Of course, if you are not on your machine, if you are on a dedicated machine, then you might like ensure that there is always this Maven daemon running all the time, otherwise you will lose the benefits. So this part was about like bare metal building. Now what I want to show you is how we can do that inside of containers. As already hinted, it's a bit different, if not completely different. So the baseline here will be different. It's just a stupid Kotlin project that I have created. And then I have a multi-stage Docker file. I will build with the JDK, I will run it with the GRE, and as you can see, I will be using the time to check that the time command to check how long it takes. And here you might notice the Docker Buildkit. I will explain it a bit later. I don't want to use the latest optimizations that you might already be using. It's just to give me the baseline. So the project is the following. Stupid project, I don't care. The POM, it's a regular Spring Boot application with Kotlin. The important bit is the Docker file. As I mentioned, it's a multi-stage build, 2 stages. The build stage, which runs the JDK to create the package, and then the GRE that takes the jar from the first stage and that runs it. And when I build this project, actually what happens is that I have the following time. It takes around, again, 2 minutes to build it. And the reason for that is that it takes a long time to download the dependencies. So here, because I'm running inside a container, by default, I will download the dependency all the time. So the protocol that I will use in all the next steps will be the following. I will use the embedded Maven wrapper. Between each run, I will add a single blank line in the source code so not to cache the previous build. And between each optimization, so each approach that I show you, I will remove the image again to discard any layer that I could have cached. I just start from scratch every time. First technique, use Buildkit. As I mentioned, I use this environment variable that say, hey, don't use Buildkit, but probably you have it available in Docker already. And depending on your platform, it might be the default or not. So I am on Mac, so it's the default, so I need to explicitly disable it. What I seem to understand is if you are on a Linux platform, you need to explicitly enable it. So check the documentation, whether it works for you or not. By default, without doing anything, it should bring some performance improvements. And in my case, well, not that much. It's still around 2 minutes, more or less. The reason for that is when I'm trying to build, by default, Buildkit will try to cache layers. But since I only have like one single layer, then it's not that interesting. And let's do better. So the most important optimization technique when you are using Docker is to use layers. Regardless whether it's Maven, Gradle, whatever, you should always add layers. As I mentioned, I add a single blank line in my source code every time. So since I have a single layer and my code and the dependencies, everything in the same layer, it invalidates the layer because the hash code is different. So every time it needs to re-download all the dependencies. And actually, it's the time that is where the engine spends, it's the place where the engine spends the most time, is downloading the dependency every time. So what we want to do is actually we want to have separate layers. So let's check how we can do it. And now I've added an additional layer. So the first layer will be to have the standard stuff and then get dependencies. And again, I will go offline. It's the same as -0. And then afterwards, only I copy the source and then I create another layer, which means that now if I change something in the source code, the dependency layer is untouched and it is cached. So I can reuse it, and now we can check the results. Here, the first run takes actually more time, but afterwards every run is very, very fast because, again, as I mentioned before, the place where it takes the most time is downloading the dependencies. You are actually bound by your networking speed, and you don't want that. So, like, caching the dependency is actually quite a smart thing to do. Now, there is another problem. What if I want to change a single dependency? Because now I have a layer where I have all my dependencies. So if I have snapshots, for example, and every time the snapshot is updated, then it invalidates this layer. And what I need to do? Well, reload all the dependencies that I don't want. Buildkit actually allows you to mount a volume during the build, and that's very different from during the run. It's only possible with Buildkit so far, and what you can do is you can invalidate the layer, but there is still an underlying cache. Let's see how we can do it. It's an experimental feature, so you need to specify these commands, Dockerfile experimental. Afterwards, here you do the exact same, but here I'm back to my single layer because I don't care about invalidating the layer. If all my dependencies are already cached, then I only need to download the dependencies that are changed. So it doesn't change that much. I can keep this single layer, and the syntax is like mount tab cache and say which folder you actually will be caching, and of course read write. The rest is just as before. That's the first stage. And then we can have very, very good build time. And when I say very, very good, it's actually very, very good. Obviously, again, the first run takes the most time, but afterwards, since we are discarding, downloading all the dependencies, then the build time is super short because it's a super stupid project. Now, here, in the last run, I changed the dependency itself. And what you can see is that it increased the build time, of course, because it needs to download the new dependency. I've changed the Kotlin version, but it's much faster than re-downloading every dependency. So if you are using Buildkit, and probably you already are, then it's a no-brainer. What I try to do also is to use the MVND daemon inside of the Docker build. So like inheriting from MVND and trying to get it out. And it doesn't work that well, probably because the reason that MVND is so great outside of Docker is that it keeps the JVM warm, and in that case, it's not that possible. Here, you might see that Buildkit itself and actually not that great result compared to the baseline. I assume it's probably not relevant. It should be close to 0. Again, you might do your own benchmarking with probably better check marks. But yeah, here the volume mount is actually really, really great at making things better. It's close to the layer stuff, but you don't need to think about the layers. You can do that yourself, of course, but in that case, every time you change one single dependency, the layer will be invalidated. You will be back to normal build time. With the volume mount, you don't care about how you organize your layers, like the dependencies they are cached. You can like change a single one, and all the others they are kept. You don't need to download them. So I believe the volume mount is actually the way to go. As I mentioned, Buildkit and the Maven daemon, not that interesting. I have thought about a way to keep like a Docker container with a Maven daemon, and well, I don't know how to connect them together. If you have, if you are a Docker expert and a socket expert, probably because I will need to have some socket communication. But then I'm on Mac, so I have an additional abstraction layer. Well, whatever. If you've got hints, you're welcome. I will be happy to hear them. So if you want very quick wins outside of Docker, just use the Maven daemon. It's a no-brainer. You install it. There is a package for every package manager, probably. If not, just use the zip. It will be good enough. And then you will see performance improvements just like that. If you are using Docker to build, use Buildkit. Again, it should be the current default on Mac. It's not on Linux. Enable it in that case and use volume mounts. It's going to speed up your build like you wouldn't believe. And if you want further, well, I've given you some like different hints in each case. So you might use them to iterate from there if you want to go like further and shave off some more minutes or some seconds, depending on your initial build time. Thanks a lot for your attention. You can find everything that I've told you in this video in written formats. The blog posts are pretty exhaustive, I believe. So if something was not clear, perhaps it's better written. Just read them. You can follow me on Twitter. And again, if you're interested in the API gateway, well, check API 6 because it's an API gateway the Apache way. Thanks a lot and have a good day.